This. Thank you. Hi. I'm very happy to be here, and thank you for having me. As you said, my name is Amit, and today I will be discussing Chrome and WebRTC and how we can combine these two to cause some problems. And for those with a keen eye, I've used the -EQ from PowerShell because I'll be using PowerShell. This is a concept though, so you can use this concept to not targeting specifically Chrome, and you'll see what I'm talking about in just a sec. So, as I said, my name is Amit. I'm a security researcher at Votiro, and what we do file sanitization, and I'm doing the security research at Votiro, and prior to that, I was working for Checkpoint, focusing on exploit kits, and I used to skate, I swim, and I play the guitar, and so that's pretty much for that. Okay, so exposition for this research is quite interesting for me because I was, when I first read about WebRTC, I thought, okay, this is a very cool protocol for me. It allows for peer-to-peer file sharing and webcam and audio and whatever you want to do. And it's easy and you don't have to install anything additional other than the browser. So it's very cool. But on the other hand, the slightest misuse and you can do very nasty stuff with it. And that's what we'll be discussing today. And I'll be showing two scenarios that I came up with. But obviously, I'm aware that there are more scenarios. And so if this talk inspires you and you come up with further scenarios, please contact me. I'd be more than happy to learn, to see them. And that's pretty much it. So before we begin, this is a post-exploitation talk. I'm discussing the case where we are already in, and now we want to stay there, and we want to gate the data out without being detected. And I'll be addressing at the end some critiques about post-exploitation, because some people are claiming that post-exploitation is not as interesting as the exploitation itself. So let's save that to the end. Post-exploitation. So it's very interesting in the organization part to consider post-exploitation because it can tell you a lot about what's going on in your organization. If you can detect a machine as an infected one because it has some sort of a weird process or something, or if you dig deeper, it might even help you identify what infected your machine. Is it a banking Trojan? Is it a ransomware? Or so forth. And if you look at the information that's being transferred in and out, you might be able to know what's being targeted. What are the secrets they're trying to get? What's the main goal of this infection? So this is the general concept of what to look for in post-exploitation. And what's actually being done is, for example, I can look at a specific process in that machine and I can ask myself, okay, how did this process came to life? What spawned it? Does this process tree make sense? This is in terms of a process. I can look at the domain. If this process is contacting some kind of a domain or IP, I can ask myself, is this a legitimate domain? Is this a legitimate IP? Maybe it can help me identify the specific malware type or malware family. And I can also look at the traffic. If I can actually go in and see what's being transferred, I might be able to realize what's going on my environment. And so this is generally what it looks like. For example, a suspicious process tree. We've got WScript. It's a JavaScript launching a decoy Word document and doing some stuff. This is a Bitcoin address in the process name. So this is probably not a good thing. And if you see this, then you might be aware that, okay, this machine is infected, and I might want to look further into this machine. But it doesn't tell me a whole lot about what's going on. I have to look deeper. And for example, if I'm looking at the domain, and this is from the ransomware tracker website, these are all payment gateways from ransomwares. And I'm sorry that the ransomwares are not so fashionably lately because we've gone to cryptojacking and crypto mining. But when I started this research, ransomwares were the latest craze. So these domains are related to ransomwares, and if I'm seeing a machine trying to reach one of these domains, I might be able to know, okay, this machine is not only infected, it's been infected with a ransomware, maybe Loki, maybe Cerber, and so on. And The last part is the data. For example, this is an exploit kit infection. The line before last is the actual exploit. It's a flash exploit, so I might be able to know, okay, this machine has been or is trying to get infected by Internet Explorer using Flash. So these are all steps that organizations can take in order to realize what's going on in their machines. But the thing is, it's never ending. So you've got a malware, it's doing something, you catch it, that's the end of this cycle, and in the other cycle, they do something else, and you try to catch it again, and the process continues. So I looked at this and I said, okay, what if we can come up with, I don't know, a generalized formula which will help us achieve a better post-exploitation stance. And I thought, okay, if I want to exfiltrate data out of an organization, and which is, I guess, a main goal of every infection, I need to think very carefully on three specific things. I have to think about the process that's the main infector, the process that's exfiltrating the data. I have to think about where the data is going and how it's actually being transferred, because I can get caught on each of these steps separately and ending my infection. So I suggest, and obviously this is not my formula, guys have been discussing this for a long time, I suggest that if we use a legitimate process, communicating with a legitimate server and using an unidentified, hopefully even better, encrypted traffic, then our chances of getting caught would be decreasing. So this is the formula, and we're going to tick off one by one until we reach a generic attack, which we can use, and then I'll show you some scenarios that I came up with. And I actually want to start with the last one, unidentified traffic. And in order to do so, let's talk about WebRTC. How many people here know WebRTC? Heard of it? Oh, cool. So WebRTC has been around for 5-6 years, something like that, I think, being developed, and it's the abbreviation of Web Real-Time Communication, and basically what it does allows you to have peer-to-peer communication, user-to-user, using the browser. They like to claim that it's only the browser, but you have to connect to a server. It's called the signaling server in order for you to be able to connect to the other user. But once you've been connected, you have a completely peer-to-peer connection. You can do a lot of stuff with this, and we'll go over it in a sec. And this is a big deal because we don't have to install anything. Unlike torrents that were in the past, and you had to install some drivers, you have to install some programs, you have to configure your firewall. You don't have to do that. WebRTC as a protocol takes care of all of this, using the mediating server to connect you with the other user, and then it's completely working. And to build on top of that, WebRTC uses UDP, which basically doesn't have any security or encryption protocol, but the WebRTC guys have implemented two security protocols, DTLS and SRTP. Each of them works for a specific part of the WebRTC phases, let's call it. So for example, I log into the WebRTC site, and then the WebRTC tries to connect me with another user in a peer-to-peer fashion. And this is the DTLS, this is where the DTLS comes to play. It's the datagram transport layer security, very much like the TLS protocol, but for UDP packets. And once we've been connected, we have the SRTP protocol, which secures the data connection, the peer-to-peer connection, encrypting the data that's being transferred. So far, this is all I want to go into WebRTC. I'm not going to discuss how it's being implemented and what's going on. This is the general concept. This is the communication protocol I'm going to point for you guys. And so now we can check this off the list. We've got unidentified traffic. So far, so good. Moving on, I want to have a process communicating online, and I want it to be as, I don't want it to be suspicious at all. And if I'm looking for a non-suspicious process talking online, what's the first thing that comes to mind? A browser, right? Everybody has a browser, it doesn't matter which kind. You can either use the big ones or Internet Explorer, it's up to you. And Everybody uses them. It's not suspicious as it has been in the past. And as it so happens, WebRTC is implemented by default in all of these browsers since these versions. And I think Chrome is version 60 something, 70 now, for example. So since version 28, 29, it's being implemented by default. You don't have to do anything. And it's enabled by default. It doesn't need or require any flags. It simply works. So I have to ask myself, are we done? Is this enough for me to call it checked off, let's call it? Well, almost, because when WebRTC was developed, the developers were aware of these capabilities and how you can abuse them. And so they thought, okay, we will add some security mitigations, restricting the usage of WebRTC capabilities only after the user have allowed them specifically by user interaction. So if you want to use your webcam using WebRTC, you have to allow it with this prompt. Same goes for the user feedback that you get. You get the audio feedback or the screen capture. And so all of this stuff are very bad for me if I want to hide my activities from the user. And as it turns out, you can actually supply, I'm discussing Chrome, but it works for other browsers as well. You can actually supply the browser, upon launching it, some arguments which will disable or enable some capabilities. And for example, if I'm doing some automation testing and I'm using Chrome and I want to test WebRTC, these annoying user interaction prompts will be very bad for me. So I can simply disable them. Upon launching Chrome, I'll add use fake UI for media stream, and then Chrome wouldn't bother asking the user for his permission. The webcam would work, screen capture would work, audio works, no fuss, no nothing. Simply like that. And now I think we can actually call it complete, don't you think? Because, for example, if I covertly launch Chrome with these arguments and point it to a video chat site, I can gain hidden surveillance on my victim. Okay, just for example, and let's put a pin in this, we'll go back to this later on. And so far, we've got a legitimate browser and we've got our legitimate unidentified traffic. And just to show you the connection between these two, this is from the WebRTC security documentation. It's talking about the browser trust model. And yeah, it specifically says that if the browser cannot be trusted, then all of the security assumptions made by the WebRTC protocol could be dumped because it's based all security assumptions on the browser. If something happened to the browser, then this protocol's security is worthless. And so, browser, unidentified traffic so far, and let's move to legitimate server. And I'm guessing most analysts here can identify a suspicious server or suspicious domain just by looking at it. You can look at the TLDs, right? .xyz, .top, .apple, whatever. And you can look at the whois information and see that the domain owner is unknown or it's lacking all sorts of information and so forth. You can look at the suspicious subdomains, you know, where's my money, Apple payback, all of these kind of stuff. And you can look at the IDNs and homographs and as well. So what I'm trying to say is it's pretty easy to identify a malicious or suspicious domain. And what exploit kits do, usually, they have two ways of operating. They either spawn these domains and they live for a day or two and then they switch to another one. Or what they do, they use a compromised site. So they hack into a site, make it host their code, or they inject a redirection iframe or something. And then it's really hard to realize what's going on because the site itself is legitimate, it's just being hacked, and it's being used to redirect traffic and all sorts. So this is similar to what I'm trying to do here. Since WebRTC has been developed, some guys have developed WebRTC sites. You've got group chat, video chat, file sharing, and so on. And people have uploaded these sites online for free for the community to use and test WebRTC. And these sites are completely legitimate. I mean, there's no suspicious behavior going on. And this is exactly what I'm aiming for. I want to use these sites to hide my traffic. And So far, I think we can call it a legitimate server complete. And I think in terms of the formula, we are done. So we're going to use the browser, communicate over WebRTC using these sites as the cover for our communication. And hopefully we will be able to achieve some covert actions. And so I prepared, as I said, 2 scenarios. And the first one, you're going to have to excuse my animation skills. You'll understand what I'm talking about in a sec. So the first scenario is pretty easy. And as I said, I'm not discussing infection whatsoever. So the infection stage is done. Okay, the user has been infected. And what happens, let's say it's a document, right? So the user has opened the document, has enabled content, and so forth. And so in the background, Chrome has been launched and has been redirected into a legitimate WebRTC video chat site using the use fake UI argument to disregard all security mitigations. And this is a predefined video chat room that the attacker has already set up in advance. And once this all happens, the attacker gets a constant stream of video surveillance on the victim, which is pretty cool. But the thing is, when you open the webcam, you get this tiny LED showing that the webcam is on. And usually on the latest laptops, it's hardwired into the webcam. So when the webcam gets power, so does the LED. And there's not much you can do about it with the software. But if we use only an audio feed that does not turn on the LED, then you get a constant stream of audio surveillance in the background. And you might say it's persistent for as long as the user does not reboot his machine, the process will remain there, and you'll get an audio feed on that user. And I'll show a video now, and I've used it for the video surveillance scenario because it looks cooler, but I suggest audio feed because it's more covert, but you do you. And before we begin, okay, so this is the attackers now, what we're looking at. The attacker is setting up his chat room. It's called the attacker. And then it's going to decrease in size, and we're going to see the victim opening the document, infecting himself. And then in a small corner above, we're going to see the attacker spying on the victim while the victim is playing solitaire. So yeah, as you can see, open to RTC, that's the site, completely legitimate. And this is the infection part, as I said, not that interesting. The user can be infected in either way. Yeah. All is good. The user continues with his activities, and check the attacker side above. And you got some more video surveillance on the user. And yeah, this just keeps on going. I play solitaire and I lose at the end, by the way. Okay, so this is bad enough, right? Cool? What do you think so far? Okay, thank you. And so when I was showing this to some friends of mine, they said, okay, that's cool, but let's talk about second stage payload and how you can do something like worse with this. And apparently WebRTC supports file sharing as well. And there are specific WebRTC file sharing sites which you can use. And I'm guessing you kind of realize where I'm going with this. So this is the animation to show it. So we have our peer-to-peer connection, and we transfer the malware to the user for execution. And the way I chose to implement this, and I'm aware that this might be not the best way to do it, and you can do it in memory and not save anything to disk, but I chose to do it like that because it's easier. So, for example, you were infected, the user was infected, PowerShell is running, and it writes a local HTML file to the disk. It has an iframe connecting to that WebRTC file sharing site, and the mainframe controls the iframe with JavaScript, eventually downloading the file. I know it's a lot to comprehend, it's kind of a mess, but when you write a local HTML file to the machine, trying to contact an HTTP file, you encounter the same origin policy that's being enforced by the browser, which is a problem. That's exactly the thing. File, trying to access HTTP, but the browser so kindly supports the disable web security argument. You can add it alongside the use fake UI if you want to, And then you shouldn't have any problems according to Chrome's documentation. So this should take care of that. But apparently this is not enough, because now we get another problem. We've got a local iframe, which its origin is null, trying to reach an HTTP website. So that's because of the frames that we used. But apparently, if you add the user directory pointing to a random directory. So the whole thing about the user directory in Chrome is that you can have two users on the same machine having different configurations, and you can tell Chrome, okay, you start with this configuration from this directory, or start Chrome with this configuration from this directory according to the user. But as it turns out, if you point it to some random directory which has nothing, Chrome will spit out the default configuration file. And this is what it takes to make disable web security works. I don't know why. So I asked them, and they said it's by design, and it's a no fix. You can check it out. This is the bug details. And so I said, okay, if it's by design and it's a no fix, by all means, I'm going to use it. Yeah. And so this is what it looks like. We're going to see the victim infecting itself and in the background logging into this file sharing website. And after that, we will be moved to the attacker, and we'll see how he sets up the malware and actually transfers it to the victim. Interesting thing about Chrome is it doesn't let you upload exe files. So I kind of change it to .malicious, which stands for nothing, but the malware my PowerShell script can actually handle this. Okay. So once again, yeah, okay, so infection, this was more obvious, but this is the attacker's machine. I don't know if you could spot by the malicious Mickey Mouse, but this is the... So these are just actions that I'm doing because, you know, Chrome does not support exe, as I said, but you can have it whatever you want. So now I'm logging to the predefined file sharing, and as you can see, there are two users logged in, me and the victim. I share the file, which has been shared successfully. Now we're going to get back to the user, and I want to point you, there will be an error, but check out this part of the screen. You see, this is the Chrome download symbol, and the malware was actually downloaded to the downloads folder, because this is what Chrome does. And you can continue your doing, and just in a few seconds, I didn't edit it, so, oh, okay, there we go. So we have been infected with the server encryptor. It's an imitation of the server ransomware and so forth. I got this from somewhere. So, infection, right? But this, as I said, these are just some of the scenarios that we can discuss. For example, WebRTC supports file sharing. You want to have an active spying on your victim, by all means, do it. If you want to exchange data, you can you can use WebRTC as a data channel to send commands to your implant, or you can receive data from that implant using WebRTC. It's completely encrypted, so nobody will be able to know what's going on in this machine. And I don't know, you can use it for cryptojacking. It's kind of hot recently, so I added this. I guess you can do it without WebRTC, but it's cool. So, okay, so a few quick notes, and I'm ahead of time actually, so I'll talk slower. This guy, which I don't know how to pronounce his name, he did something very cool and quite similar, and he used Internet Explorer. So Edge supposedly supports WebRTC, but Internet Explorer does not. And this guy, what he did, he said, okay, I'm infecting my machine, not very interesting, and now I am using COM to initiate an, let's call it Internet Explorer process in the background. And because Internet Explorer supports WebSockets, I'm going to use WebSockets to communicate with my domain and have my commands go like this, which is very cool actually. It's quite different because, for example, WebSockets work on TCP and WebRTC on UDP. This is not encrypted. This is WebRTC is encrypted. but the general concept was very similar, so I thought, okay, it's worth showing. But if you don't want to use that, you can simply install this plugin. I saw it online, more than whatever downloads, and it supports everything. And once you've installed that, you've got WebRTC working in Internet Explorer, which you can launch with Chrome. And I really like it. It's really cool. And that's pretty much it. So yeah, I know final notes, it's kind of ahead of time, but yeah. If we consider incident responders looking at these attacks and trying to figure out what's going on, so in the signaling phase where the machine first connects to the mediating site, to the signaling server, let's say it's HTTP, so you can see a machine connecting to a WebRTC site and exchanging the signaling data, but if it's HTTPS, then you can't even tell what's going on in there. And the site is legitimate, as we said, and the communication is UDP and encrypted. So far, so good, appears legit. Taking a step further, if we look at the second scenario where I've downloaded something to disk, it was actually Chrome downloading something into the downloads folder. This appears to be regular behavior of Chrome, nothing to suspect so far. And in the audio surveillance, I've saved nothing to disk. I've simply launched Chrome with arguments, and so there's nothing to suspect in this sense of the attack. And as I said, I wanted to address the post-exploitation critics, and a lot of people have been telling me, okay, so you're already in the machine. You can do whatever you want. You know, you want to exfiltrate data, so exfiltrate the data. Why do you need to go through all of this fast to do what you're trying to do? And I say, okay, getting in is only half the job. If you haven't planned what you will be doing after you got in, then this attack won't succeed. So if you want to steal something, if we think about a thief going into your house and then walking outside with the TV, I mean, this is something that you might be aware of and you might be able to stop. So getting in is only really half the job. You have to get out or stay there or get the data out in a covert way in order for this attack to work, in order for you to make money. Because you might be getting money from getting in, but the actual money that the attackers make are from stealing something or getting information to someone. So this is for all the post-exploitation critics out there. Let's talk about some blue notes. If you want to protect from this attack, you can disable WebRTC. Hopefully, it's not that easy as you think. I mean, you can specifically tell the browser using the Chrome flags page, disable WebRTC communication. The thing about WebRTC using the signaling protocol is that WebRTC tries to find open ports it can use. So it's kind of hard to block in terms of firewall, but you can try to inspect UDP ports to try to see if it has WebRTC communication traffic or communication aspects, and then you can go to that machine and check out what this user is doing with WebRTC. In terms of the browser, specifically Chrome, you can prevent other processes from launching Chrome. You can say only the user, only, I don't know which one launching Chrome. And moreover, you can say these arguments are the one I want to be supplied to Chrome, nothing else. No use fake UI, no disable, no nothing. Chrome, this is how it goes. Any other way, I want it blocked and notified and so forth. And so these are the blue notes. And I thought about some red notes as well, because when I started this presentation, this research, Chrome and Firefox did not have the headless mode, which is relatively new. So I launched Chrome, and using PowerShell, I immediately caught the window and sent it to the background. But you can use Chrome headless mode, or if you don't want to use headless mode, you can use Puppeteer or Selenium, which are environments you can use to control Chrome. And actually, I've found out that Puppeteer supports arguments, for example, use fake UI for media stream. So it works. And what about mobile devices? So in terms of iOS, I'm not so sure, but in terms of Android, WebRTC is completely supported. So you have to think about your infection mechanism and everything, but this works in WebRTC. WebRTC works in Android, so feel free to try it out. and some cool research that I've seen along the way. So this is the WebSockets and Internet Explorer, some connectionless backdoor ideas. I highly recommend you to check it out if this interests you. And this guy, what he did, he used a browser to transfer commands to his implant in the machine. So it's quite similar. I'll be sharing these slides anyway, so you can have a look at them afterwards. And quite ahead of time, but I'm finished. So, questions?
Questions?
Sorry?
You have a peer-to-peer connection.
Yeah.
So you have a peer-to-peer connection, and that means you would be more or less in the same case as on the machine trying to transfer again from the other side. So,
I'm having a hard time understanding the...
okay, so you compromise the machine,
Yeah.
and then you transfer to another machine using peer-to-peer, using WebRTC. From that machine, then you have to do it again, because you are more or less in the same situation.
No, I'm not sure I understand.
So you establish a peer-to-peer connection.
Yeah.
You transfer already the files to the other machine. So what do you do there?
From the attacker's machine?
Yeah.
Whatever you want.
Yeah, but would you not consider this machine vulnerable because you have a peer-to-peer?
It's a peer-to-peer connection to a specific victim, which I have an implant within that's in my control. So if I got the files, I can close the peer-to-peer connection on my side, the attacker's side, and then it's done.
Okay. Good, thanks.
Yeah, sure.
You were talking about the suspicious process tree.
Yeah.
And in your example of the file transfer, actually it's PowerShell executing WebRTC and then monitoring the appearance of something in the download folder. Is that right?
Yeah, as I said, the infection part is less the thing that I've focused on. I mean, you can have, for example, a user being infected by a Word document, DDE downloads something that sits in the background, and after 2 days writes an HTML file. I mean, you can play with it as much as you want. This was just a plain example to show what it looks like.
My question was, did you, because you were writing a HTML file, a local HTML file to bypass a series of things and then pass the arguments in Chrome to disable security features, did you dig into further how, if you could make this HTML file and launch Chrome to be completely self-sufficient without requiring a PowerShell to execute the downloaded file, or being able to get commands over WebRTC to browse files just from the HTML file and then upload files from the victim to the attacker and so on?
So the reason I chose a local HTML file with an iframe is just I wanted to address this specific file sharing site which had a download link. So it was in terms of the site. But if you build your attack and you know the file sharing site that you use, or you set up your own legitimate file sharing site, that you can work with it whatever way you want. Okay. Understand?
Thank you.
Okay.
Thank you. Is it possible to enumerate the initial UDP connection to the RTC stuff? Like if you want to write a rule, let's say you are on Ubuntu, and inside the Ubuntu you have a Windows machine that you are trying to infect, whatever. And on Ubuntu you want to write some snort rule. Would it be possible to like detect the initial phase of the UDP connection to the...
I haven't tried it. Sounds like you can, like from your question I think might, yeah, but I don't know. Haven't tried it.
Okay.
More questions?
Okay.
So, thank you.
Thank you very much, guys.